All right, everybody, how we doing today? Good afternoon, happy Friday. Good to see some new faces, some uh, old friends. Welcome to the Science Core Heuristics for Open Science Outcomes and Learning Open Science Team Meeting. Um, Today we'll be discussing the climate and agriculture lesson, particularly the lesson from NASA Acres. So we have Jacob Orser here who will be giving us a brief presentation and who also co-authored the lesson that we'll be reviewing today. So it's a very exciting day for me because I'm excited to talk about this subject. So thank you so much, Jacob, for your time and for being here with us. Um, Let me just briefly make sure that I have all my settings here just to record. Um, Geez, I think it's recording. Uh, okay, so again, just so everyone knows, this meeting is being recorded. So if just so everybody's aware, we have a code of conduct that we borrowed from uh, Gentleman et al. And this TOPS February meeting. This is very early in the open science journey. So we kind of want to borrow these principles during our meetings. So for today's agenda, we'll just say briefly introduce ourselves. If you can't speak, you can put it on the chat. I know some people are coming through the phone. We'll hear about our guest speaker, Jacob Orser, and the NASA Acres program. We'll get a little bit overview of what the lesson is, what the activity is going to be. Of course, we'll get into providing some feedback as we have with other lessons. And then we'll come back and join together to, final remarks that we can share so that, hopefully we can make this lesson better. And, researchers like Jacob can get some feedback. So just a brief icebreaker. This is kind of like a fast, speed icebreaker. Just say your name, where you're from, and what your favorite vegetable is and why. Since we're talking about agriculture today, I thought this would be appropriate. So I'll go first. My name is Juan Martinez. I am with Season, which is a research center at Columbia University in New York City. My favorite vegetable is probably like a yellow squash because it's very sweet and tasty, and you can use it in pastas or you can make fries out of them. They're very versatile and good for you. So the great vegetables. Okay. I'll pass it over to Miguel. If Miguel, you can unmute yourself and just quickly, introduce yourself.
My name is. Can you guys hear me? Can
I
you guys hear me?
apologize, Miguel. Were you the one you said that you were gonna put in a chat, right? I'm sorry.
Yeah, I'll put it. I'm so sorry. I'll put it in
No
the chat right
worries.
now.
Great. Thank you so much. I'll move on to Julian. Julian, if you're there.
Good afternoon. My name is Julian. I'm currently attending NOU, National Louis University, studying computer science. And my favorite vegetable would be zucchini, especially the round ones, because I've been eating them since I've been a little kid, mainly steamed. And yeah.
Great. Thank you so much. Ahana.
Yes. Hello, everyone. Good afternoon. I am Ahana Aziz, and I'm from Bangladesh. Currently, I'm doing my bachelor's in here in India in computer science engineering. And my favorite vegetable is cauliflower because in Asia, cauliflower is quite very much popular and it's very versatile. My mother cooks it very well. That's why I like it very much. So yeah, thank you.
Thank you. Thank you. All right, Robinson.
Yeah, good evening, everyone. Robinson Muiro. Organization for Vista Limited. Not a vegetarian, so but I would say rotis.
Yummy. Yes. Crystal, if you can unmute yourself, please go for it.
Hello, my name's Crystal. I'm with National Louis University. I'm a senior there. I'm doing computer science, and my favorite vegetable is broccoli because I love air frying it, like seasoning it and air frying it.
That sounds good. I'm gonna try that. I have an air fryer, so I'm gonna try that. And Jacob, if you're last but not least.
Hey everyone, I'm Jacob Orser. I'm with NASA Acres out of the University of Maryland, and my favorite vegetable is probably tomatoes. I didn't like them until I grew them myself, and yeah, I think that's what makes them my favorite.
Oh wow. Do you know what kind of tomatoes? Because you got cherry tomatoes,
Yeah,
grape
I think
tomatoes.
it was yeah, cherry.
Oh yes, nice, nice. Okay.
Yeah. Mhm.
All right. Well, thank you everybody for being so quick and sharing with you today. Hopefully, this helps you get to know everybody a little bit. You see that, we have people in Chicago, out in India, I believe, or Bangladesh. Is that what you said? We also have people in Maryland and elsewhere. So it's great to see that we have, people from all over the world. Um, So, as I mentioned, we have Jacob Orchard today from the University of Maryland. He's a program specialist with NASA Acres, and please correct me if that's wrong. So I will stop sharing here and give the floor to Jacob.
Can everyone see my screen? All right, awesome. Thank
Yes.
you.
Yes.
Yeah, so hi everyone. My name is Jacob Orser. I'm a program specialist at NASA Acres. And I'm really excited about this TOPS module and kind of present you guys some of the background behind this module. All right, so basic presentation, I'm going to talk about NASA Acres, talk to you guys about what we're hoping to get out of the module, and then kind of where we can go, where we need help from here. So a brief background, NASA Acres is a consortium on focus on food security in the United States, primarily sort of supported by NASA. The program lead is Dr. Alyssa Whitcraft from the University of Maryland. And our research focuses on U.S. agriculture, and we do this by defining and outlining our essential agricultural variables, which help us define the use and terms of reference for farmer data. So our goals for EAVs is to define what might be most helpful. And so the two that we're focusing on for this module are crop land and crop type mapping, and then crop and crop type area estimations. So brief overview about farmer data governance. As part of open science, I think it's really important that we share our work in this. We've outlined that model agreements with our partners, and so this means to be transparent with farmer data and how we're using it. And we know that sometimes open data has unintended consequences, so we want to make sure that we're really explicit about how we use our data and how what outcomes are coming from that data use. All right, so let's get into it. This module, we've created it for early career scientists who want to think about remote sensing through the view of agriculture and understand a little bit more about remote sensing. This module walks through the current impacts of sea level rise and kind of what the impacts are currently. We didn't want to single any single farmer out, so we took a regional view rather than a single farmer's view. And our results are derived, and we want to give the power right back in the hands of students and make this a really easy module to figure out different insights and apply it to different areas. And we're proposing this not as a polarized issue, but kind of a contextualized area of concern. And that's kind of how we center our discussions at the end of this module. For those who don't know about saltwater intrusion, this is kind of a brief graphic, highly oversimplified, and don't mind my artistry. This was kind of my brief crack at it. So as we all know, this is kind of like the classic sea level rise. It's just the increase of water from the sea. As you know, storms increase, we just get salt water being deposited onto croplands and crop fields, which leave behind deposits of salt on fields. But this next area is kind of the area that we also want to look at, and that we found over through research at the University of Maryland. And this is salt water coming up from this saltwater sledge because of pumping of fresh water. So as we continue to pump fresh water, eventually it becomes more salty, and due to pressure differences, higher concentrations of salt enter the pump. And then finally, there becomes a cone of depression because of this loss of pressure, and we can have the decreased elevation of land, and eventually roots can just be pulling straight from salt water rather than the fresh water they were used to. So that's a brief overview. I think the module is able to walk through that a little bit as well. And there's more an outside reading that I'm hoping that we can kind of get into. But really what to expect from this module is the combination of saltwater rise with the cropland data layer from the USDA. And then we're going to bring on top of NASA satellite data using Landsat and using NDVI as a metric for crop health. I think combining these three data sets, we're hoping to see the differences in crop health in areas that are closer versus further away from salt water. These are our expected outcomes, visualization, and use case. So we want this to be able to be visualized, and then if people want to use it in other areas, be very easily applied to other areas. And this is tying back to our EAVs that I talked about at the beginning, cropland mapping and crop type mapping. And we're really trying to highlight those as areas in which need to be researched and kind of highlighting the reasons why we might want to research these. And so finally, some things that we are hoping to look out for and hoping to receive maybe some feedback on are, is there room in this module to look at other crops, look at other trends, kind of maybe do a trend analysis? As far as a review of the module, how does the flow feel? Is like the remote sensing aspect complete? Is there anything that gets skipped over a little bit too quickly? And then finally, the contextualization of the results. Is it clear like what we mean? Are there any other conclusions that might be interesting to be drawn? So yeah, if you guys have any initial questions, I'll also be on the rest of this call. So yeah, any questions now?
Well, I have an initial question. I was wondering if you know if when those pockets get created, if they sink the land, and if that maybe data corroborates,
So
the
I'm not sure if there's like a noticeable elevation change. I think it's more just higher access to like the roots being accessing water loss. And I know that from like we were able to tell where like pumps were installed based off of LiDAR of like increased depth over time from that. Um, but
yeah,
in
wow,
terms of salt water, yeah, I'm not 100% sure if we're
that's
able to detect it from that. Yeah, question.
yeah. If anybody has any questions, I know sometimes you just you need a little bit time to process. So other other way, you can also drop them in the chat.
Thank you.
So um, as Jacob was mentioning, uh, this lesson also uses a peers data, which oftentimes when you'll request it using your Earth data login, um, and then once you do request it, you request a certain um, data layers, and then kind of it sends you two email notifications. The first one letting you know that it's been accepted. The second one letting you know that it's ready. And this all works with a task ID that you can see here in the bottom. But sometimes this can take 10 minutes, sometimes it takes longer. So just in case, I pre-generated one and I've added it to the lesson. But in any case, if you're curious or if you want to explore further on how to access this data, it's listed as well in the lesson, and you can just grab it and do it on your own as well. So just as a reminder, this is an alpha testing session, so I'm sure there'll be a lot of, or maybe not, but there could be some issues, and so we obviously want to know about them because we're still in the alpha phase of this. So this is what's so great about these meetings is that we often get to test out things as they're coming out. So I'll put it in the chat again if anybody does not remember what where to go. This is the 2I2C page. And then as you remember, it's only write privileges. I'm sorry, there's only reading privileges, not writing privileges. So for your comments, please use the Google Doc that I've added here on the chat. And again, use suggestion mode or add a comment so those, your comments and your feedback can easily be spotted. So usually what I do is that, let me just open this one. So when you open these first, I wanted to mention use Pangeo because it seems that Pangeo has already all the packages that we need. So once you log in and you see this option, select Pangeo and use 14 gigabytes. If someone's having a trouble, getting to this point or doesn't see Pangeo, please let me know. But you should be able to see Pangeo and 14 gigabytes of RAM. Once you press start, let the server start up. In the meantime, I will go to the document. And again, on the top right is where you can change to suggestion mode. And if you select something, you can also add comments. So that is, please add your comments like that so we can spot them out a little bit faster. Once this is, give it a few more seconds. I'll put this one here and I'll put this one here. All right, so is anybody stuck? Let me just pause here for a second and see if anybody's stuck or if anybody has any questions about logging in or what is Pangeo. Please unmute yourselves. I always tell people that when they're learning, there's no such thing as a bad question, because if you have a bad question, probably someone else also has that question. So just let me know if you're having issues. Um, sometimes this takes a little bit, sometimes it's very fast. So as I mentioned, just give it some time because it may take, it's we're using technology that still hasn't been fully, you know, tested out. So gotta be patient. But yeah, if you have any questions for Jacob or myself, please unmute yourself or add them to the chat. Also, if you want to start reviewing while you wait for this Pangeo, you can start reading the Google document and start adding your suggestions, start adding your comments. If anything is not clear or you feel like, oh, this could be rewarded, please add those comments as well. All right, everybody. So if you may have opened this and the file M401 may have already been open. If it's not, let's just assume um, that it's not. So you should see something like this where there's a folder here, shared, name shared. Let me know if you cannot access it. Um, Once you get into shared, you should see the M401 Python notebook. It's this one down here, M401. Once you open M401, you will see the lesson. And again, it's kind of we got the lesson on the left side and copied it onto the Google Docs, so it should be the same. If you go scroll down, there is a part, as I mentioned, where it's going to ask you for a token. Um, let's see if this one here can run. So yeah, it should run okay if you're running these packages here. This is the first chunk. But then it'll ask you for a token. So you don't need to worry about a username. If you don't want to do that part, that's okay because further down, I've copied it. I've I've copied a token for you, and then we have, as I mentioned, the appears task ID, and I've already waited, and the status is already done. So if you just run this chunk, you shouldn't have to run, the first one, or you don't need a username or password. So you should be able to just run all of them as they are. Um, but I left all this information here in case you want to actually learn or you want to put your information and just exchange your information for your actual username and password. You can do so. Um, and so yeah, the first part is getting this requesting a token. Once you get a token, you can then request data, and that's what the task is doing. But as I mentioned, I already did that for you, so it's all down here. Um, After that, these are all commands that will actually allow you to interact with the cloud data that's on these servers. But I don't think you need a username after this point, so you should be fine. All right, everybody. So I'm gonna stop talking now, and I'm gonna leave my screen on so you see what I'm doing. If anybody has any questions, please unmute yourself. Um, we'll probably try to do this for um, probably 20 minutes. And in 20 minutes, we'll all come back and give our final feedback. All right, everybody, we have about 5 more minutes. Wanted to let you know, just wrap up whatever comments you have. So Jacob, I was, I employed a little bit of ChatGPT to help me figure out what the issue was. And then also Kit added this data set, the 5 foot TIFF
Yeah.
onto Amazon.
Okay.
So, and in this instance, it's pulling the data set from the S3 bucket.
Amazing. Slovy, did you figure out what the challenge was?
Yes, you were on the right path. It was the mask. It had to do
Okay.
something with, let me just find it here. Um, I think after the bundle, it was fine. Um, somewhere around here. Uh, yeah, I think it was something with the mask.
Okay.
Oh, first I had to do this part here
Okay.
for the division. Um, I essentially broke down, I had to break down the other equation that you had
Mhm.
into the denominator and then um, you know, replace zeros with NaN.
Okay. Amazing.
And then do this, and then that's when that error that you remember that error that you were getting about dividing,
Yeah.
it stopped doing it. And so after that, I think it was something to do with this mask right here. Uh, I changed to a sort of different type, like it was a binary type or something like that.
Yeah.
And then once that was changed, um, I think it's all pretty much the same.
Hmm.
Yeah, I think this
Sweet.
is all the same. And then something was happening here. I think this is where the null values were, or the maybe the mask was masking these out, and the division of it was. So I think I had to tell it if it's something weird, just give it a zero.
Yeah.
So
Okay.
it just gave me this value here and here as well.
Okay.
But
I'm glad it got sorted. Um, yeah. um, Worked
yeah.
itself out. Yeah, I figured it was something with the data structure. I feel like,
Mhm.
yeah.
Yeah, it was, you know, if anything, if one feedback is that I know Rasterio is a little bit complicated because you need to set the SRS, and it was really great how you managed to like reproject it and fit and make sure that it all had the same columns and the same, width. And I always find that very challenging,
Mm.
when dealing with rasters. So I thought it was great that you had that there. I just feel like for me, I I wouldn't know where to begin, you know, to to understand that.
I mean, that's the beautiful thing about GIS and remote sensing is like there's more than one way to solve a problem, and like this is just, you know, so by no means was this like yeah, it's just the way I figured it out. Um, if there's other ways, yeah, more than happy to add more, change it up. But yeah, this was a
Yeah.
lot of bits and learn. I think that's where like I was talking about multiple types of geospatial data, and like I was trying to include vector and raster stuff. And then at some point I was like, I think we're all gonna do rasters, and that's gonna be okay.
Yeah, no problem. Yeah, I mean, there are other lessons that we have that do use like the GATM, um, it pulls GATM from the cloud and some makes some zonal statistics.
Mhm.
Um, so yeah, but in any
But
case, it's a great lesson, and it's great that uh, it's a very clear example of open science. Where you started something, you sent over a Python notebook, and then I took it and made some changes,
yeah,
AWS, the bucket, whatever.
yeah,
And hopefully, the folks that are still here we can get their feedback too, and make this a better lesson.
yeah, that's amazing. Thank you guys again, everyone on the call, for helping out. It's really awesome to see it's taking shape. And yeah, like I mentioned, the first V1 was not where we're at, but yeah, I'm liking where the progression is going, and thank you everyone for helping out.
Thanks, I appreciate that. And I just wanna put some people on the spot. I do have a document that I'm taking some notes. So if just go around the room and perhaps give some notes. If anybody has any final remarks, please unmute yourself, and I can share all these documents with you. They're all you know in the Google Documents. Jacob, just for your knowledge, we also put them on Zenodo as a Zenodo entry. We use people's org IDs and they share them with us, and just try to provide credit anywhere we can. So I think I'll start. I'll be more interested in hearing about reprojecting data because it's such a confusing topic, at least for me. Um, all right, so let me put Ahanaf on the spot. Ahanaf, if you so kindly unmute yourself and let us know if you have any feedback, any last moment, last minute
Yeah,
feedback.
yeah, it's amazing content, I have to say, and brief introduction uh, of the soil nutrition, soil nutrition diagram would be much more perfect. And overall, I
I'm
would say,
sorry. I'm sorry. I couldn't hear that last comment. Sound a little low.
okay, yeah, I talked about the soil intuition problem. Soil intuition in the Google Doc that you wrote, that a brief introduction or a brief note, brief explanation would be much more easier to the learners. And overall, the topic about reprojecting and such a versatile topic is amazing, and it's overall a great. I would say that.
Great. Thank you so much. Crystal, if you don't mind just sharing your last thoughts of the
Honestly, I
lesson.
think I'm in the same boat as you. Just learning a little bit more because it is kind of a confusing topic. But I really enjoyed the module. It's like really clear and easy to understand.
Great. That's a great feedback. I appreciate that. Julian, how are you?
So overall, I also enjoyed the module. I also agree that it has great content and good fluency. One suggestion I do have is maybe adding a brief description of what some images are or what they represent in this module?
Great, great. Thank you so much.
Yeah.
I know Miguel is unable to speak, so Miguel, if you do, have some comments, please add them to the chat. And lastly, Jacob, just any comments, takeaways for you, for this meeting, any feedback for us?
Again, super appreciative of everyone taking their time to review this module and go through it. I definitely think I'm not an educator, and so I appreciate you guys helping me figure out where the problems are and where we continue to build. But yeah, again, super appreciative of everyone here. Thank you.
Thanks, Jacob. And again, we truly appreciate your time. One of the goals for this project is to get people exposed to the researchers like yourself and these products that NASA has, and try to give people that don't have that opportunity to interact with these tools. So, we work with a lot of students that are early career, and we try to, show them some of the stuff that NASA's doing, some of the data sets available, and, with their help, what they do with us, they also get credit and they get exposure, and of course, we always try to support uh, whatever they try to do with their careers. So, yeah, so again, thank you so much for helping us out and for showing us these really interesting and cool stuff that you're doing, because hopefully a lot of these students will be working in similar projects. So yeah, thank you everybody. Thank you again. Um, and have a great weekend.
Thank you so much.
Stop. Yeah,
Thank you.
take
Have a
care.
good week.